Welcome to the session on Introduction to Computational Problem Solving. So let's have a recap of what we covered in our previous session. We started with writing Scratch programs in our previous session. So within that program, we studied that what is a variable. So if you're able to recall, we defined variable as a data container that can hold one value at a time. And each variable has a name. So that variable can be used for a particular purpose in a solution of a computational problem. Okay. So the next thing which we studied last time was that we tried to characterize a problem. So when say what is the problem, what is the computational problem which we are interested in solving, that essentially means that we need to clearly and correctly understand and identify input and output. By input, we mean that what has been given as part of the problem. And the output means that what is expected after the problem has been solved. So the second very important pillar of this entire problem solving exercise is that how to solve the problem. So learning how to convert the input into the desired output is essentially what we call a recipe. So we design a recipe, we design a sequence of steps which help us to convert the given input into the desired output. Or like in computer science perspective or computer science terminology, we call it an algorithm. So algorithm is a solution idea which can be written in any language. It could be a plain English language or could be some programming language. Once we convert our algorithm or our solution into the language of a particular programming language, then it is called a program. So for example, the kind of solutions which we have been writing, which we wrote in our previous session, and we'll be writing more solutions in this session, they are called programs, and those are the programs written in Scratch language. So that program is actually is the crux of that entire problem solving exercise while using a computer programming language, because that yields a solution of the given problem which we started with. So if you are able to recall from our previous session, we talked about different examples. So one example which we should recall, and then we move to the new problems, is that given a number as the input, our task was to figure out whether that number is even or odd. So before we start attempting the solution or programming part, we should be able to understand that what does it mean by even and odd. So if we know even and odd, then we could translate that concept in the language of computers. Or in other words, we just need to translate that idea in the language in any of the programming languages which we are using. So in our case, we'll be translating that thing into Scratch, and then we'll expect our program to solve the given problem. So what we did in our previous session was that we watched this kind of stuff happening in Scratch. So let's first analyze the program which has been given on the left-hand side. This is what we call a script. So when flag is clicked, that is the event which happens. We have a variable which we have created whose name is input. So in this example, that variable has been initialized with 89. So as a result of this whole thing, what happens is that when this line is executed, when this particular line is when this line is executed, that means that a variable is created in the computer's memory. So that variable or that space in the computer's memory is named as input. And that value which we store inside that variable is called the data of that variable. And in this example, we are using 89 as the data. So this whole thing will be happening at the backend in computer's memory as a result of this particular line. So once this input variable has been set to 89, then the next thing is this whole block. So this block is called if else block. So this is a select, we also call it selection statement because, or sometimes we call it decision statement because it makes a decision about a particular a situation. So over here, if you look at this part, we have defined in this green diamond, we have defined a condition, we have defined a question. So in our context, we'll be calling it condition, that we have defined a condition. And that condition is that input is being divided over 2. So input is a variable, so value of that variable is being divided over 2, and we are computing the mod. So if you're able to recall from our previous session, we said that by mod, we mean that we are talking about the remainder. So this is a simple integer division that 89 is divided over 2. Somewhat like this, what we can see on screen that 89 is being divided over 2. So if we try to divide it over 2, these 2 4s are 8. So we get 8 over here. So the remainder of 8 minus 8 is 0. And then we have 9. We bring 9 down. We divide 9 over 2. This is again 4. So 4 2s are 8. And we are left with 1 over here. So now when I say integer, that means that we are talking about numbers which don't have a decimal point. So in integer division or this kind of division, what we do is that we just stay at 1. As the remainder, and then we compute 44 as the quotient. So when we apply this particular operator, which is called mod, this operator, so this essentially this mod gives us this remainder, which is 1 in our case. So then that mod is being compared. So input mod 2, which is 1, which is coming from here. This is being compared against 0. So in other words, our condition is being formulated as if 1 equals 0. And we know that 1 does not equal 0, so that means that the condition is false. So if the condition is false, then the second, the part which is inside the if statement, which is this part, this will be skipped over, and we'll be jumping to the else part. So else part will be executed when the condition is false. So if the condition is true, we'll be running the if part. If the condition is false, we'll be running the else part. So in this case, our else part will execute and that will say all. So as a result of this thing, our sprite is saying all. Uh, so that's what is the output. So I hope everyone is with me, and like if you have any questions, you can ask the questions. Okay. So let's have another have a look at another example, which is that we have we are into the same program. The only thing which we have changed is that our input has changed this time over here. So we, instead of giving it some odd input, we are actually passing it 578 as the input. So the variable is created in the same way as we saw in our previous example. So in the memory, we'll be having a variable whose value is set as 578, and name of this variable is input. So this is what happens as a result of this set statement. So as we move forward, we check this if condition. This condition has the same condition which we saw in our previous execution. So input is divided over 2, and we are interested in remainder. And we know that if we divide 578 over 2, one thing which we'll get is because of this last 8, we'll be getting remainder as 0. So we are not interested in the quotient, but the remainder is 0. So if the remainder is 0, that 0 equals 0. So we can have a quick look on this like this. At 578 is divided over 2. So 2 2s are 4. One is the remainder, then we bring in 7. 2 8s are 16. So you get 8 over here, we get 16 over here. And 1 is the remainder. We bring in 8 down. So 2 9s are 18. So we get 18 over here. And as a result of this whole thing, our remainder is 0. And we are actually interested in this remainder, which is what is mod. So as this remainder is 0, so this says 0 equals 0. So when 0 equals 0, then the condition, we say that the condition is true. And if the condition is true, then this part will be executed and else part will not be executed. So both of them are mutually exclusive, which means that at one time, one part will be executed and other will be skipped. So because we have mod 0, so that's why our sprite is saying that the number which has been given in the variable input is E1. All right. So this is the this was a kind of recap. This is the kind of stuff which we studied last time. So let's move forward. So in this whole situation, if you look at the program once more, there is no part of the code, there is no part of the recipe, there is no part of the program which is being repeated again and again. So essentially, we have written the tasks once, and then those tasks are being executed from top to bottom. So, but there could be a situation that there are some tasks which we want to repeat. So if we have to repeat something in Scratch, so what we do is that for that purpose, we have two options to solve that issue. One is that we keep on writing that repeatable code again and again. So for example, if we ask our sprite to say hello 5 times, we can write say hello, say hello, say hello 5 times, like one after the other, and then the sprite will be able to act upon the instructions. But if that number increases, then this whole solution idea is not scalable, which means that if I have to get this whole thing done, let's say 5,000 times, then I will have to write 5,000 times say, which is not an easy task, which is not even a good idea. So a better choice is what we call that we use loops. So loops are the constructs in a programming language which help us to repeat some tasks. So the task which we want to get repeated, that is enclosed inside a loop. That's what we'll be seeing in our today's session. And then the program will keep on repeating. So our like today's session is completely focused on using loops in Scratch. And let's start with loops in Scratch. So as part of that whole exercise, we'll be solving different examples in Scratch. So let's land onto the first problem. That's a simple counting problem that we want our sprite to do forward counting. By forward counting, we mean that we want our sprite to count numbers, let's say from 1 to 20. So sprite should be just counting 1, 2, 3, 4, and so on up till 20. And we'll be inserting a small pause of might be like 30, might be like half second or so in between every count, so that we can visually see that sprite is really saying that counting. So let's jump to our Scratch screen. So is the Scratch screen available? Can you please type in the message if the Scratch screen is visible to you? Can you see the Scratch screen? Oh, good. Thank you. Okay, so this was our previous program. So what I'm going to do is that I'm just trashing this program, and we are left with this variable, which is when flag is clicked. And what we do is that this entire panel is what we have, like these are the different types of logs or options which are available to us. So we go to variables first because we have to do some counting. So that variable which we have been using for odd and even, that is there. So if you want to remove a variable, we can just right click on this and click on delete. So those variables which are there can be deleted as well. So this is an empty place where we can create new variables. So let's create a new variable. So we can name it anything. So for example, let's call it counter. Click OK. And now this counter variable is available over here to us. So what we do is that we come here and we set the counter to 1. Why we are setting counter to 1? Because our counting process, the kind of counting which we wanted to do, has to start from 1 and we want to stop at 20. So what we want to do is that once this counter is set to 1, so we bring in this looks block, which we are familiar with. So we drag this thing, say, and within say, instead of displaying this term hello, we replace this thing with counter. So we drag counter and we place it over here. So it says say counter. So if I just click on the flag, you can see that my sprite is saying 1, which means whatever is value of counter is now being set by the sprite through this say statement. So say, in other words, is an output statement. It is helping us to output something on the screen in this output window. Okay, so but now our task is that once this one has been said, we want to move to the next counter. And when we say we want to move to the next counter, so one easy task is that we use this statement, which is called change, and we ask is change counter by 1, which means that counter will become 1. Once the counter has been changed by 1, this counter should become 2. So if we run this program, if I click on the flag button, which is go button, I click over there. So sprite is still saying 1, but an important thing which you can observe over here is that the value of counter in the computer memory has become 2, because after saying counter 1, it has changed counter by 1. So the previous value of counter was 1, and it has been incremented by 1 due to this last statement. So our next task in that counting process is that we want the sprite to say that counter again. So that when we say set the counter again, that essentially means that I want it to go back over here. We want it to go back over here. Like from change, it should go back to say. And it should say counter again, which means then it will be saying 2. And then it should update the value of counter. It should become 3, and then go back once more. And then it should say 3, and so on. It should keep on repeating that thing, right? So we need to figure out that how many times we need to repeat it. But this is so these two statements, essentially, the statements which are over here, they have been like disconnected from the remaining program. These are essentially the repeatable tasks. We want our program to repeat these tasks. So we call them that these are the repeatable task, because we want to use this say thing again and again. And every time one counter has been set, one output has been displayed, we want to increment by 1. So what we studied or what we discussed at the start of the session is that if there is something which is repeatable, so for that purpose, what we do is that in order to capture in order to support that repeatable thing, we use a term which is called loops. Right. So the good thing is that in Scratch, there are like a couple of loop options available. So let's get into them. So if you go into control, there is something which is called repeat. So if I bring in this repeat thing in a broader structure, it looks like somewhat if statement or if block. But as the name suggests, so if I write something over here, that will be repeated 10 times. So we need to figure out that how many times do we need to repeat it. So at this stage, what I do is that I just bring in this say and change statement inside the repeat block, and let's keep it as 10 for a while, and then see that what kind of behavior can we expect this sprite to exhibit over there. So because I'm recording this video, so for like the people who will be watching this video later on, you can just pause the video over here and figure out yourself that what will be happening on the sprite side. So what will be the kind of output or outputs you will see on the screen. So take a pause and then figure it out yourself. And once you come back, you'll be able to see the the actual output. So if you figured it out on your own, so if I click on the flag button, so the kind of behavior which I might be expecting is that I'm just seeing 10 over here. So if I run it once more, so you can see some counting happening over here, but that is happening at a fast pace. So with the human eye, we might not be able to capture what is happening. So we go back to our control tab of different blocks, and we bring in this wait thing over here, that every time it works, it has to wait for some seconds. So we might be asking it to wait for half second. So 0.5 seconds, we just put it over here, and let's see what happens over here. You can see 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this time we might have been in a better position to observe this whole thing, that some counting is happening. But our task at the start was that we want to do this whole thing 20 times. So let's make this statement as repeat 20. So this repeat thing has been changed. Now it is repeat 20. And then let's see that what kind of stuff happens over here in the output. So counting has started from 1 and it is moving forward, reaching 9 and 10, 12, 16, and it has stopped at 20. So our fundamental objective, or like the basic purpose for which we wanted to like write this program, which was like the problem number one, that we wanted to do some forward counting. So that has been addressed. So again, an important suggestion for the people who would be watching it offline or in asynchronous mode, just pause it over here, analyze this program, get comfortable with this program. And once you are completely comfortable and fine with this solution, then that should be the only case when you move forward, because we'll be gradually increasing our complexity of problems which we'll be solving in our coming problem sets. So we've just solved problem number one, which is let's do forward counting. Let's move forward. So our next problem, which is problem 2, is that let's do reverse counting. So by reverse counting, we mean that we need to go back. And in this time, let's say we want to go back from, let's say, 100 to 90. So our start point has to be 100 and our stop point has to be 90, and we want to do the reverse counting. So let's go back to scratch again. And so this is our program. So this time what I'm going to do is that I'm going to slightly modify the existing code, and that should help us to land onto the code of the desired problem. So the problem is that we want to do counting starting from 100. So our counter is initially set to 100 and we want to go back to 90. So we need to count because 90 is the last output which we want to display. So on fingers, just count that how many times we need to repeat this same thing to print all numbers from 100 to 90. And if you have successfully counted them back, they are actually 11 numbers. So this time we write here, repeat 11 times, say counter, and change counter not by 1, instead change counter by -1 so that we can count back. So the first counter value was 100 and then we should go back to 99 and so on. And then keep on taking a pause. And then these three statements, which I'm just dragging to show you visually over here, that say, change, and wait have been put inside the repeat block. So that means that these three things will be repeated again and again as we go along. So if I click on the go button, so counting has started from 100. You can observe over here in the output. And the last thing which is displayed over here is 90. Let me do it once more and you can have a close watch on the sprite that where the counting starts from and where does it stop. Okay. So, this is what is reverse counting. So let me slightly modify the question, and we want to do reverse counting from 100 back to, let's say, 80. And this time we want to only display the even numbers. So we know that we are starting from 100. So the immediate previous number, which is even, will be at a distance of -2 from 100. So that means that if we subtract 2 from 100, we'll be landing to 98. So that should be our next output. So let me slightly increase this time interval so that we can closely see that what is happening. So let me make it 0.8. Let's have a look at the program once more. What we are doing over here is that we are starting our counter from 100. We are starting our counter from 100. We are repeating 11 times, and each time we display the counter. So the first thing which will be displaying on screen is 100. Once we are done with that thing, we subtract -2 from the counter. We change the counter by -2. The next counter is now 98. So once we go back to say, our counter will be containing 98. So the next thing which will be displayed is 98. And we will be doing this thing 11 times in the backward direction. So let's try to see that whether we are able to see the desired output on the screen or desired behavior on the screen. We started with 100, 98, 96, 94, 92, and 84, 80. And see, we stopped at 80. Okay. One small homework for you, which is an ungraded one. So if you keep an eye on the variable itself, that has become 78. But it is this the last value which is being displayed over here is 80. So later on, after the class, just figure out that why the counter has become 78. But the last thing which is being displayed is 80. Let's move to the next problem. So we just solved problem 2. Our problem 3 is that we have been given a number as the input, and we are interested in displaying all of its factors. So factors are the numbers which divide that particular number completely. So for example, if we take a number 6 as the input, so its factors are going to be the first factor, which is where our search process will start from, is 1. So 1, because if we divide 6 over 1, our remainder is 0. So the next factor is 2. Why 2 is the factor? Because if we divide 6 over 2, our remainder is 0. The next factor is, you may guess, and that is 3, because if we divide 6 over 3, the remainder is 0. So is 4 a factor of 6? No, because if we divide 6 over 4, the remainder is 2. Is 5 a factor of 6? Again, no, because if we divide 6 over 5, the remainder is 1. Is 6 a factor of 6? The answer is yes, because if you divide any number over itself, the remainder is 0. So for 6, the factors are 1, 2, 3, 6. So what we want our program to do for us is that we'll be setting an input as 6, and it should be displaying all possible factors starting from that number itself, and then moving to, starting from 1 and then moving to that number itself. And then it should check all possible candidates in between, that whether there are factors of 6 or not. So the same way, if our input is, let's say, 7, so we'll check for 7 that we will start our search process from 1. So 1 is a factor of 7. We'll check 2. 2 is not a factor of 7. Then we'll check 3. We'll check 4. We'll check 5. We'll check 6. All of those numbers from 2 to 6 are not factors of 7, because they don't completely divide 7. But 7 itself is factor of 7. So in this case, the possible answers are 7. The possible answers are 1 and 7. So this is the kind of stuff which we want to solve. So let's go back to our scratch screen. Okay, so let me, what I'm going to do is that I'm going to trash the components which we already have over here. So let's restart this program from scratch. So in variables, we had like only one variable. Just for the sake of simplicity, I'm deleting that. So this is our like empty program at the start. So we need to have some variables. So one thing which we need to have is that we need to create a variable which should be storing the input. So we name it as input. So create OK. So input has been created over here in the variable palette. We drag this set statement over here. So set input to this term in, so set input to something which user will be giving us. So for example, somewhat like we talked about 6. Now, if you are able to recall the kind of stuff which you were doing manually, so there was an important thing which you were doing, and that was that besides input, there was another number which was being checked as a possible factor. So we need to create another variable, which is a candidate factor. So let's name it as candidate. So it's a candidate factor. And by candidate factor, we mean that this is a number which we need to check whether whether it is a factor of input or not, whether it completely divides the input or not. So if it divides, then we just like display over here. If it does not divide, we don't need to worry about that thing. So but like if you are also able to recall that thing, so our first candidate which we need to check with is 1. So candidate is set to 1, our input has been set to 6. and how many times we need to repeat this whole process, and what is the kind of thing which we need to put inside that repeatable part. So if you are able to recall that odd even code, so we have to write somewhat similar to odd even code. We just drag this if statement, which is without else. This is a simple if statement. And within this if statement, we plug in this equality operation. And within this equality, if you look over here on the first variable, we need to put something over here, and that is this mod operation. So we drag mod and put it over here. So far in structure, it is somewhat similar to what we saw in the case of odd and even, but actually we're going to do some different stuff over here. So what we want to divide over what? So we want to divide our input. Sorry, we want to divide our input over the candidate. So if input mod candidate is 0, then that means that candidate is a factor of input. And if it is a factor of input, so what we need to do is that we go to our looks palette and we need to bring in this say statement or say block. And within say, what we want to display is that say the candidate. So because this candidate is the candidate which would have divided the input completely. By dividing an input completely, we mean that if we divide input over the candidate, our remainder is 0. So we would have got that thing over here. So with this whole say statement, we also do some small thing, and that is that from our control palette, we bring in this wait thing so that we can see that wait for 1 second after displaying one possible candidate, so that we can observe, or we can like slightly increase it. We can ask it to wait for 2 seconds. So this is the kind of thing which we want to repeat. There's one small but very critical thing which is missing over here. So just pause the video, figure it out yourself, and then complete this before we enclose this whole thing within the repeat block. And that missing thing is that we want to change the candidate. Once one candidate has been checked, we need to move to the next candidate, and for that purpose, our candidate has to change by 1. Another important thing is that this change statement or change block has to be written outside if block. Why? Because we have to change the candidate irrespective of whether the previous candidate was a factor or not. So now this whole block is essentially the repeatable block. This is the kind of thing which we want to repeat. And how many times do we need to repeat? We want to repeat it input times. So we started our input, so we want to do this whole exercise 6 times, because we'll be checking all possible candidates from 1 to 6. So it will be 1, first candidate will be 1, then it will be 2, then it will be 3, then it will be 4, then it will be 5, and then it has to be 6. So from controls, we bring in this repeat block over here. And from variables, we bring in the input. So we ask this repeat block to repeat itself input times. And we enclose this whole repeatable block within this repeat block. And this is how our program should look like. So now if I click on the flag, so let's try to closely observe what sprite says. So sprite says 1, then it said 2, then it said 3, and then it said 6. And it has missed 4 and 5 in between, because 4 and 5 are not the factors of 6. So if I change the input from over here, if I make it 7, so we click on the flag, it is 1, and then it is 7, because 1 and 7 are the only two possible factors of 7. You can check it for a few more statements. So let's check it for, let's say, 15. So click on the flag, the first factor is 1, the next is 3, next is 5, and then the next is 15. So it has only 4 factors, 1, 3, 5, and 15. And all of them have been displayed over there on the screen, on the sprite. So this is an extremely important program, because we really need to understand that how the problem is being solved and how these statements have been put in a certain sequence, how the recipe is being developed. essentially, your task, your goal, your core job is to design a decent, sensible recipe for the computer so that it can follow that recipe and generate the desired product. So in our case, the desired product is just to figure out whether just to figure out the possible factors of a given input. So again, the same recommendation which I shared with you a while ago, that if you're watching this in this video in an asynchronous mode, just pause it over here, get yourself completely comfortable with this code, try to do some paperwork and how things are happening at the happening at the back end. And if you're comfortable, that should be the only case that you're moving forward. Otherwise, please feel free to share your questions with me over any of our communication channels. Let's move forward. So we've just solved problem number 3, which was given a number, display all of its vectors. So our next our next problem is problem 4, which is given a number, display its first 10 multiples. So by multiples, we mean that, for example, if you've been given a number 2, so its multiples are 2 is multiple of itself, then 4, then 6, then 8, then 10, and so on. So essentially, we are actually talking about the table of 2. Or if the input is 5, so we're talking about the table of 5, or mathematical or multiplication table of 5. So our first multiple is 5, then 10, then 15, 20, 25, and so on. So this way, we have to just display the first 10 multiples. So if you have been comfortable with the solutions which we've discussed so far, then the solution for this problem should be somewhat very similar to what we have just solved. And I would strongly suggest that you should pause the video, try it yourself in Scratch. If you succeed, that will be very good. But otherwise, you can get back and just follow what we are doing over here. So in this case, because we have to, this is a relatively simpler task. So we have been given an input. So let's say we start with an input 2. So our task is to display its table 10 times. We don't need to have a candidate as such. So what we do is that I just trash this set statement. So we put it repeat over here. And because we have to just display it 10 times, so I just keep 10 over here in repeat. So we'll be repeating it 10 times. And what we have to say is something which we need to figure out. So essentially, we have to say, table of 2. So when we run it for the first time, there is no if. So the table is something which is not conditional. So we can just bring somewhat simple say statement. And within say, we need to figure out that what do we need to say over here. So because as we are saying, we are interested in a table. So that means that we have to bring something from here which has to do multiplication. So multiplication is done using this star statement. So we have to multiply 2 things. One is that we have to go to variable. We have to multiply our input with something. So when we do it for the first time, this something should be 1. Next time it should become 2. The next time it should become 3. Next time it should become 4, and so on. So essentially, we want to multiply input with candidate. And I just drag this thing over here and say, and this says that say input times candidate. So candidate needs to be set to something like 1 at the start. So that we can start our table with 1. So I think candidate might not be a very good name. So let me just create another simple variable, which is somewhat like counter, right? So candidate is something whose candidacy has to be checked. So just for the sake of better nomenclature, I'm using this variable counter over here. So set counter to 1. And again, over here, I bring in the counter, input times counter. And then we put this says change statement that change the counter by 1. And we don't need to have this if statement. So let's go over this thing that what we have designed so far. So our input is set to 1. Our counter has been set to, our input has been set to 2, counter has been set to 1. And we are repeating this whole thing 10 times. What do we do when we repeat it 10 times? So when we run it for the first time, we'll be multiplying input with counter. So input is 2, counter is 1. So 2 times 1 is 2. So it should say 2. Then it should wait for 2 seconds and change the counter by 1. So the next counter becomes 2. So when it goes back to say, because I hope you are able to recall that once it reaches over here, so it will go back to say statement, and it has to do this whole thing 10 times. Uh, so when it goes back over here, uh, counter has become 2. So 2 2s are 4. It should be able to say 4. Then it should be able to say 6. And this whole thing has to be done 10 times. So let's see that what kind of behavior we see over here in the execution. 2, 4, 6. Just keep an eye on what we can see over here. So it is moving forward. And it has stopped at 20. So let just keep this output screen clean. Let me remove this remove this variable, which was an addition inherited variable from our previous code. So this is how things are happening. It is running again. So let me stop it here and let me ask it to do the same thing for slightly bigger number. Let's say 8. So now this time it has to just speak out table of 8. 8, 16, and 24, 32, 40, 8 6 are 48, 8 7 are 56, 8 8 are 64, 8 9 are 72, and 8 10 are 80. And it has stopped at 80. So all these numbers which have been displayed over here on the sprite, these are multiples of 8. Because if we divide those numbers over 8, we'll get remainder 0. Let's move to our next column. Okay, we've just solved problem 4. So problem 5 is that given a number, figure out whether that number is a prime number or not. So this is an important thing which we need to figure out. Given a number, figure out whether that number is a prime number or not. So what is a prime number? A prime number is a particular integer that has exactly 2 factors. For example, so if you're able to recall your school math, figure out that is 6 a prime number? The answer is no. Why? Because its possible factors, which we saw in one of our previous solutions, is that they are 1, 2, 3, and 6. So in other words, the number of factors is now 4. There are 4 factors, 1, 2, 3, and 4. So that means that this does not qualify this definition of prime numbers, that the prime numbers have exactly 2 factors. So it is not a prime number. But if we think of 7, so 7 had 2 factors, which we figured out in our previous example. They were 1 and 7. So the total number of factors which 7 have, their total count is 2, which means that this fulfills this definition of having exactly 2 factors. Hence 7 is a prime number. So this is what we mean by prime numbers. So let's go back to Scratch and figure out the solution. I would strongly suggest that if you have been with me till this moment, just pause the video and try the solution on your own in Scratch. And once you've tried, then come back to this video and map or verify your solution. So your solution might be equally correct with slightly different logic. So you just need to figure out that it should be able to pass all test cases. So we are back to our Scratch screen, and this time what I'm going to do is that let me slightly modify this code. So this code is actually somewhat similar to what we have seen for prime numbers. Uh, so we are setting our input to some number. We set our counter to 1, and we repeat it sometimes. Are you able to recall that how many times do we need to repeat? we were supposed to repeat it input times. So input has to be dragged over here and we put it over here. So let's use that the same nomenclature which we're using for factors. So we need to have another variable which is called candidate. So that candidate has to be set to 1 at the start. And we are using this counter variable for a different purpose. So this counter variable should be set to 0, and essentially it means that how many factors have we computed so far. So this counter will not be displaying the factors. Instead, it will be just counting or will be updating itself as we come across a candidate which is a factor of input. So in other words, once this whole repeat block is done, we'll be able to see the value of counter. If it is 2, then that means that the number is prime, otherwise the number is not prime. So within the repeat block, this time we don't need to say anything because we just need to simply count things. And so let me completely trash this code. So we just need to count things. And what do we need to count? That is important. So we need to only count the factors. Go in control, drag the if statement, which is somewhat similar to what we saw in our previous factors code. So bring in this equal thing, bring in the mod operation. Okay, what has to be divided over what? Input has to be divided over candidate. So if input mod candidate is 0, what do I need to do? I simply need to change the candidate by 1, which means, sorry, I need to change the counter by 1, which means that counter is initially 0. So as this green block becomes true, I update the counter by 1, which means that I have come across another candidate, which is a factor of input. So my counter variable is essentially counting number of factors. And what we were doing in the case of factors example, after if statement, we were changing the candidate by 1. So we'll keep on running this exercise input times. And and like major difference between this example and that factors example is that we have not displayed on screen anything so far, because we don't want to display as we are searching through that whole process of factors. So once that whole process is over, what we need to do is that we need to bring in this if else statement after the repeat block. And we need to analyze that to how many factors we have come across so far. And the number of factors is now stored inside the variable counter. So counter is representing the number of factors. So if counters is 2, what does that mean? That means that we have come across only 2 factors while searching from 1 to input. That means that if there are only those 2 factors, those will be 1 and that number itself. And in that case, we just need to say on screen, or a sprite needs to say, let's say we ask it to say prime. So it just displays prime, the word prime on screen, that your input is a prime number. Or in the else statement, if our counter is not 2, so we might be expecting our sprite to say something not prime. And that's it. So if we pass 8 as the input, so let's run it for 8, and it says not prime. And we can verify it from our this memory snapshot that why is it not prime? Because counter is containing 4. Why counter is containing 4? Because 1, 2, 4, and 8 are the 4 factors of 8. But if I give it a slightly different input, let's say 13. So if we run it for 13, it says prime because it has only 2 factors, and that's what we know from our common knowledge or basic mathematical knowledge. So let's verify it for another couple of examples. So if I give it 21, it says not prime because 21 has 4 factors: 1, 21 itself, 3, and 7. So let's check it with 49. So if I ask it 41, 49, it says not prime. Why it says not prime? Because it has 3 factors: 1, 7, and 49 itself. Last check, if we ask it to check 47, so it says prime because it has only 2 factors, 1 and 47 itself. There are there is no other factor in between. So it says prime. And so understanding this kind of logic or this level of complexity is extremely important to get familiar with the basics of computational problem solving. Again, I'm sorry for like repeating that thing again and again, but I would strongly suggest that pause this video over here and get very comfortable in depth with this whole code. What is happening around, how things are being put together in this whole recipe or in this whole script or together. And please move forward only if you're comfortable with this thing. Otherwise, do it on your own and just make sure that things are in your control and they're making complete sense. So this was our problem number 5, which was trying to figure out that whether a given number is a prime number or not. So let's move to our problem number 6, which is the last problem for today. And that is that given two numbers as input, compute their greatest common divisor. Or in some textbooks or school maths, some of the books actually mention it, they call it highest common factor. So highest common factor and greatest common divisor are essentially same. So in this example, we are calling it GCD. So GCD of two numbers is the kind of is the greatest common divisor or greatest common factor. So for example, if we have been given two numbers, one is 8, other one is 12. So what are the factors of 8? We know that the factors of 8 are 1, 2, 4, and 8. What are factors of 12? We also know the factors of 12. They are 1, 2, 3, 4, 6, and 12 itself. What are the common factors of 8 and 12? So the common factors are let's figure out the common factors. So the first common factor is 1. The second common factor is 2. The third common factor is 4. And there is no fourth common factor. So the common factors are 1, 2, and 4. And our question asks us that we need to figure out the greatest common factor or highest common factor. In that case, amongst common factors, that is 4. So 4 is going to be our answer. So 4 is our GCD, or sometimes we call it HCF. Okay, so before like attempting this whole task, we must be very comfortable with the basic knowledge of greatest common divisor or greatest common factor. So let's move to Sketch and figure out that how to address this whole thing, how to model this problem. So the major difference between this problem, so just for the sake of simplicity, let me try to trash the previous code and create altogether new stuff. So I'm destroying all previous variable. Let me delete them. And we'll be creating new variables with our own desired names. So the first variable, so in this problem, our task was to find GCD of two numbers, which means that we need to have two inputs. So let's call them input 1. And we need to have another input, another variable, which let's call it input 2. So this time we have two inputs. Both of them need to be set at the start. So user will be giving us those two inputs. So set input 1 to something, set input 2 to something. What else do we need to have? So we need to know, we need to have a very critical thing, and that is the variable GCD. So GCD has to be a variable which we need to figure out. So, but who is going to be the GCD? We need to check different candidates. So we need to check different candidates. Candidate is another variable. So we bring in that candidate over here. So we start our search process with 1. So the critical thing is that if you have to just check that whether candidate 1 is a common factor of input 1 and input 2. So what I need to check? I need to check that whether input 1 mod 1 is 0 and input 2 mod 1 is also 0. So if you go in operators, so there is a slightly new thing which we didn't use so far. That is this AND operation. So I drag this AND operation. That means that this can contain two sub operations. And those sub operations are that we need to bring one equal in the first diamond. We need to bring another equal in the second diamond. And for both of them, we need to bring in this mod operation because essentially we have to check the divisibility. So we drag and bring in mod in both of them. So this is how it should be looking like. And we go to the variables. We fill the first one with input mod candidate. If input 1 mod candidate is 0, that means candidate is a factor of input 1. Then there is something which is very critical to understand, that is AND. That means at the same time, we also need to check that input 2 mod candidate is also 0. So this whole bigger diamond green operation will be true only if input mod candidate is 0 and input 2 mod candidate is 0. So if both of the inputs are divisible over candidate, that means candidate is a common factor of input 1 and input 2. So if it is a common factor of input 1 and input 2, so if it is a common factor of input 1 and 2, so what we need to do is that we need to go into controls. And from controls, I need to bring in this if statement. Within this if statement, we just need to plug in this bigger green statement. So if this if condition is true, and a very important thing which I need to do is that that means that this candidate, because candidate is a common factor, so this could be the GCD. So that means that we need to set GCD to what? To the candidate, because candidate is a common factor. And why we know this is the greatest common factor? Because our candidate is starting from 1 and will keep on repeating this whole block certain number of times. Let's say input 1 times. So we need to bring in this repeat block. I put it here, put this if inside it, and I ask it that this whole thing should be repeated input 1 times. So another important homework is that what if I change to input 2? Will the answer change? Please try it on your own as a homework and figure out that what kind of change is expected if I replace input 1 with input 2 over here in the repeat block, or whether it will be correct or not correct. And the last thing is that once this whole thing has been checked, we need to change the candidate by 1. So as our search process of candidacy is starting from 1, so every time candidate is changing by 1, which means the first candidate is 1, then 2, then 3, and so on. So the last green statement, which will be true, will be given as a relatively bigger candidate. And that will be stored in GCD. So once this whole thing has been said, then we can ask our sprite to just simply say GCD. So we ask it to output the GCD. So sprite should be able to display the GCD. So let's start with our example, which we have just solved manually, that if our inputs are 8 and 12, so what is the kind of behavior which you can see on the screen? So for our inputs are 8 and 12, let's click on the flag and see what happens. See, its sprite says 4. Which means 4 is the greatest common divisor, and that's what we know mathematically or conceptually that this is the true answer, and that's what we have just figured out in our previous calculations as well. Let's change the number. So what if I ask it to figure out the greatest common divisor of 10 and 12? Before we ask the sprite, we should know that what is the greatest common divisor of 10 and 12. So once you do it manually, you should be able to figure out that that is 2. So let's say what sprite says. Sprite also says 2, because there's no other factor greater than 2 which divides 10 and 12 both. Or if I ask it to check this thing for, let's say, 13 and 12. Again, the greatest common divisor is 1 because there is no other common factor other than 1, which divides both of them. So we can check for some slightly more interesting numbers. So let's say check it for 20 and 50. So what is the greatest common divisor between 20 and 50? It should be 10. And our sprite also says 10. Let's check it between 20 and let's say 200. What is the greatest common divisor between 20 and 200? That should be 20. And our sprite also says 20, which means that it looks like that our program is correct and it is completely and correctly computing the GCD in the desired way. So that's it for today. Please do practice Scratch. I'll be uploading a few practice problems with the LMS. But meanwhile, get comfortable with these examples, try to do them on your own. Like one natural example from basic math, which you can try it, that how to figure out that what is the least common multiple of two numbers. So you can try it on your own. That's it for today. Thank you very much.